The use of British wiring cable is not directly addressed in the National Electrical Code, NEC, or other applicable United States electrical codes. The provided wiring is rated for 34 amps continuous current according to the manufacturer. The equipment draws about 22 amps per phase, which is within the wiring's rating. The 32 amps per phase breaker provided by the manufacturer is appropriate for the equipment's load. NEC Article 210 requires conductors to be sized for the maximum load. NEC Article 215 states that overcurrent protection devices (OCDs) must be sized to protect conductors. Based on the information provided, it appears that the use of the British wiring cable is acceptable for the intended application, provided that it is properly protected by a 32 amps per phase breaker or fuse. There are several recommended actions to take. Firstly, confirm that the wiring is indeed BS6007 4-core 4-square-millimeter EPR insulated rubber with a current rating of 34 amps continuous. Secondly, use a qualified electrician to determine the appropriate supply fusing arrangement or breaker size based on NEC requirements. Thirdly, ensure that the supply conductors are properly sized to protect the wiring. Fourthly, obtain written confirmation from the UK manufacturer that the equipment and wiring meet the necessary electrical standards and are suitable for use in the United States. The physical diameter of the wiring does not necessarily indicate its current carrying capacity. The current rating of a conductor is determined by its construction, material, and insulation. It is important to comply with local electrical codes and regulations when installing electrical equipment. When considering the application of British wiring, specifically BS6007, within the United States, it's crucial to understand the nuances of electrical codes and standards. The NEC serves as the foundational benchmark for safe electrical installations in the US. However, it does not explicitly address wiring standards from other countries like the UK BS6007. Therefore, acceptance hinges on demonstrating equivalent safety and performance. The first critical aspect is the current carrying capacity. The manufacturer states a 34 amps continuous rating for the 4-square-millimeter EPR insulated cable. This rating needs careful evaluation against NEC tables for ampacity typically found in Article 310. The NEC provides ampacity ratings based on conductor material, insulation type, installation methods such as conduit or free air, and ambient temperature. A qualified electrician can determine the equivalent American wire gauge (AUG) size that provides a comparable or higher ampacity. A crucial point to consider is that the method of installation significantly affects ampacity. If the British cable is installed in a way that reduces its heat dissipation, the allowable ampacity must be derated according to NEC guidelines. These derating factors are outlined in NEC Article 310.15 and associated tables. The equipment in question draws 22 amps per phase. The 32 amps breaker provided by the manufacturer seems appropriately sized for this load, offering a reasonable safety margin. However, the upstream overcurrent protection needs careful coordination. The suggestion of a 60 amp supply fuse or breaker raises concerns if the supply conductors are not adequately sized for 60 amps. NEC Article 240 addresses overcurrent protection. It generally prohibits placing two overcurrent devices in series unless specifically designed for coordination. The primary goal is to protect the wiring from overload and short circuits. If a 60 amps breaker is used upstream, the conductors supplying the equipment must have an ampacity of at least 60 amps, and the 32 amps breaker at the equipment's rear would then provide localized protection. The 4-square-millimeter cable must also be protected. It cannot be subjected to currents exceeding its rated 34 amps. The NEC mandates that overcurrent protection devices must protect conductors against overcurrents. This is usually achieved by selecting an overcurrent device with a rating no higher than the conductor's ampacity. Given that the British cable is rated for 34 amps, it needs to be protected by an overcurrent device of that size or smaller. This is where the manufacturer's 32 amps breaker plays a crucial role. NEC Article 110 covers requirements for electrical installations. It emphasizes the importance of ensuring that the equipment is suitable for the intended use and environment. In this context, suitability includes verifying that the equipment and its wiring comply with US standards or are demonstrably equivalent in terms of safety and performance. Obtaining written confirmation from the UK manufacturer is essential. This confirmation should explicitly state that the equipment and its wiring meet relevant US electrical standards or provide detailed documentation showing how they achieve equivalent safety levels. This documentation should include test reports, certifications, and detailed specifications of the wiring. The qualified electrician will play a key role in assessing the installation. They will evaluate the wiring, the overcurrent protection devices, the installation method, and the overall compliance with the NEC and local electrical codes. They can also perform calculations to verify that the wiring is adequately sized for the load and that the overcurrent protection is properly coordinated. It is also important to be aware of local electrical codes and regulations. These codes may have additional requirements or restrictions on the use of foreign wiring. Contacting the local electrical inspector is a good way to ensure compliance. When evaluating the British cable, consider the insulation type. EPR, ethylene propylene rubber insulation, has specific temperature ratings that must be considered. The NEC provides tables for allowable opacities based on insulation temperature ratings. The cable's temperature rating must be suitable for the ambient temperature and the operating temperature of the equipment. If the cable is exposed to high temperatures, its opacity must be derated accordingly. Another important factor is the grounding and bonding of the equipment. The NEC requires that all electrical equipment be properly grounded and bonded to provide a safe path for fault current. The grounding and bonding connections must be made in accordance with NEC Article 250. The British cable may have different grounding and bonding requirements than US wiring. It is important to ensure that the grounding and bonding system is properly installed and that it complies with the NEC. Regarding the physical diameter of the wire, while it may seem undersized compared to typical American wiring, the opacity is determined by several factors, including the conductor material, insulation type, and construction. The fact that the British cable has a 34 amps rating indicates that it is designed to carry a current safely. The key is to verify that the rating is accurate and that the cable is installed in accordance with the NEC. Firstly, verify the wiring specifications. Obtain documentation from the manufacturer confirming the BS 6007 standard, 4 square millimeter conductor size, EPR insulation, and 34 amps continuous current rating. Check for any certifications or test reports that support these specifications. Secondly, compare the wiring to NEC standards. Consult NEC Article 310 and associated tables to determine the equivalent AWG size that provides a comparable or higher opacity. Consider the installation method, ambient temperature, and other factors that may affect opacity. Thirdly, assess the overcurrent protection. Ensure that the 32 amps breaker provided by the manufacturer is properly sized to protect the equipment and the wiring. Verify that the upstream overcurrent protection is coordinated with the 32 amps breaker and that the supply conductors are adequately sized for the upstream overcurrent device. Fourthly, ensure proper grounding and bonding. Verify that the grounding and bonding connections are made in accordance with NEC Article 250. Ensure that the grounding and bonding system is properly installed and that it complies with the NEC. Fifthly, obtain written confirmation from the manufacturer. Request written confirmation from the UK manufacturer stating that the equipment and its wiring meet relevant US electrical standards or provide detailed documentation showing how they achieve equivalent safety levels. Sixthly, consult with a qualified electrician. Engage a qualified electrician to evaluate the installation, verify compliance with the NEC and local electrical codes, and perform any necessary calculations. The electrician can also provide guidance on grounding and bonding, overcurrent protection, and other electrical safety issues. Seventhly, contact the local electrical inspector. Contact the local electrical inspector to discuss the installation and obtain any necessary permits or approvals. The inspector can provide guidance on local electrical codes and regulations and can ensure that the installation is safe and compliant. The use of British wiring in the US requires careful consideration of several factors, including ampacity, overcurrent protection, grounding and bonding, and compliance with the NEC and local electrical codes. By following these steps, it is possible to determine whether the British wiring is acceptable for the intended application and to ensure that the installation is safe and compliant. The NEC provides guidelines for directing conductors based on the number of current-carrying conductors in a raceway or cable. If multiple conductors are bundled together, their ampacity must be derated to account for the increased heat. These derating factors are found in NEC Table 310.15 cone. If the British cable is installed in a raceway or cable with other conductors, the ampacity must be derated accordingly. In addition to ampacity derating for the number of conductors, ampacity must also be derated for ambient temperature. NEC Table 310.15 bone provides correction factors for ambient temperatures other than 30 degrees Celsius, 86 degrees Fahrenheit. If the British cable is installed in an area with a high ambient temperature, its ampacity must be derated accordingly. Voltage drop is another important factor to consider when selecting conductors. The NEC recommends that voltage drop not exceed 3% for feeders and 5% for branch circuits. If the British cable is used for a long run, voltage drop may be a concern. The voltage drop can be calculated using Ohm's law. The resistance of the conductor must be known to calculate voltage drop. The resistance of the British cable can be obtained from the manufacturer. The insulation resistance of the British cable should also be tested to ensure that it meets the required standards. Insulation resistance testing is typically performed with a megameter, also known as a megger. The megameter applies a high voltage to the insulation and measures the leakage current. The insulation resistance is calculated from the voltage and current. The insulation resistance should be above a minimum value specified in the NEC or other applicable standards. The NEC requires that all electrical equipment be listed or labeled by a recognized testing laboratory, such as Underwriters Laboratories, AL, or Electrical Testing Laboratories, ETL. Listing or labeling indicates that the equipment has been tested and meets the applicable safety standards. If the British cable is not listed or labeled, it may be difficult to get it approved for use in the US. Some testing laboratories may be able to evaluate the British cable and provide a listing or labeling. However, this can be a costly and time-consuming process. The NEC also contains requirements for the installation of electrical equipment in hazardous locations. Hazardous locations are areas where there is a risk of explosion or fire due to the presence of flammable gases, vapors, or dusts. If the British cable is to be installed in a hazardous location, it must be approved for use in that location. The NEC contains specific requirements for wiring methods in hazardous locations. These requirements are found in NEC Articles 500 through 516. The British cable may not meet these requirements. If the British cable is not approved for use in a hazardous location, it cannot be installed in that location. The NEC requires that all electrical work be performed by qualified persons. Qualified persons are those who have the skills and knowledge necessary to perform electrical work safely. Electrical work should not be performed by unqualified persons. Electrical work can be dangerous. It is important to take precautions to avoid electrical shock and other hazards. Always turn off the power before working on electrical equipment. Use insulated tools. Wear safety glasses. Follow all safety rules. If you are not qualified to perform electrical work, hire a qualified electrician. The NEC is a complex and comprehensive document. It is important to consult the NEC and other applicable standards before performing any electrical work. The NEC is updated every 3 years. It is important to use the latest edition of the NEC. The NEC is available from the National Fire Protection Association, NFPA. The NFPA also offers training courses in the NEC. These courses can help you to understand the NEC and to perform electrical work safely. The NEC is not a law. However, it is often adopted by state and local governments as law. In these jurisdictions, the NEC is legally binding. It is important to comply with the NEC in these jurisdictions. Failure to comply with the NEC can result in fines or other penalties. The NEC is a valuable resource for electrical professionals. It provides guidance on how to perform electrical work safely and in compliance with the law. By following the NEC, you can help to prevent electrical accidents and to protect yourself and others from harm. Always prioritize safety when working with electricity. Never take shortcuts or try to save time by skipping safety procedures. Electrical work can be dangerous, but it can be performed safely if you follow the proper procedures and take the necessary precautions. The equipment in question operates on a three-phase 208 to 240 volts alternating current (VAC) input. This voltage range is common in the United States, particularly in commercial and industrial settings. The 208 volts is typically derived from a 208 volts/120 volts Y-connected system, while the 240 volts is typically derived from a 240 volts/120 volts delta-connected system. It is important to ensure that the equipment is properly connected to the correct voltage system. Connecting the equipment to the wrong voltage system can damage the equipment or create a safety hazard. The equipment is supplied with a 32 amps per phase breaker at the rear. This breaker provides overcurrent protection for the equipment. The breaker is designed to trip and interrupt the flow of current if the current exceeds 32 amps. This helps to protect the equipment from damage due to overloads or short circuits. It is important to ensure that the breaker is properly sized for the equipment. If the breaker is too small, it may trip unnecessarily. If the breaker is too large, it may not protect the equipment from damage. The wiring provided with the equipment is labeled BS 6007. This is a British standard for electrical cables. The wiring is 4 square millimeter EPR, rubber insulated. The manufacturer claims that the wiring has a current rating of 34 amps, continuous. The physical diameter of each phase wire appears to be 12 AWG wiring. This can be misleading, as the ampacity of a conductor is not solely determined by its physical diameter. The ampacity is also affected by the conductor material, insulation type, and installation method. The equipment draws about 22 amps per phase. This is within the 34 amps current rating of the wire. The concern is that if you supply the wiring and 32 amps breaker with a properly sized supply fusing arrangement or breaker, it will need to be around 60 amps, since it would not be good practice or code passable to put two fuses or breakers of the same size in series. That would seem that the wiring would then be too small. This concern is valid. If the upstream overcurrent protection is 60 amps, the wiring must be protected by a 32 amps breaker or fuse. Otherwise, the wiring could be subjected to currents exceeding its rated ampacity. It is important to properly coordinate the overcurrent protection devices to ensure that the wiring is protected. The suggestion is to confirm that the wiring is indeed BS 6007 4 square millimeter EPR insulated rubber, with a current rating of 34 amps, continuous. Use a qualified electrician to determine the appropriate supply fusing arrangement or breaker size based on NEC requirements. Ensure that the supply conductors are properly sized to protect the wiring. Obtain written confirmation from the UK manufacturer that the equipment and wiring meet the necessary electrical standards and are suitable for use in the US. It is also important to comply with local electrical codes and regulations when installing electrical equipment. These actions will help to ensure that the equipment is installed safely and in compliance with all applicable codes and standards. The NEC provides specific requirements for the ampacity of conductors. These requirements are found in NEC Article 310. The ampacity of a conductor is the maximum current that it can carry continuously without exceeding its temperature rating. The ampacity of a conductor is affected by several factors, including the conductor material, insulation type, installation method, and ambient temperature. The NEC provides tables that list the ampacities of conductors based on these factors. It is important to consult these tables to determine the correct ampacity for the conductors being used. The NEC also provides requirements for overcurrent protection. These requirements are found in NEC Article 240. Overcurrent protection is designed to protect conductors from overloads and short circuits. Overcurrent protection devices include fuses and circuit breakers. Fuses and circuit breakers are designed to trip and interrupt the flow of current if the current exceeds a certain level. It is important to properly size overcurrent protection devices to protect conductors from damage. The NEC provides guidelines for sizing overcurrent protection devices. These guidelines are found in NEC Article 240. The NEC also provides requirements for grounding and bonding. These requirements are found in NEC Article 250. Grounding and bonding are designed to provide a safe path for fault currents. Grounding and bonding help to prevent electrical shock and other hazards. It is important to properly ground and bond electrical systems to ensure safety. The NEC is a complex and comprehensive document. It is important to consult the NEC and other applicable standards before performing any electrical work. The NEC is updated every 3 years. It is important to use the latest edition of the NEC. The NEC is available from the National Fire Protection Association, NFPA. The NFPA also offers training courses on the NEC. These courses can help you to understand the NEC and to perform electrical work safely. Always prioritize safety when working with electricity. Never take shortcuts or try to save time by skipping safety procedures. Electrical work can be dangerous, but it can be performed safely if you follow the proper procedures and take the necessary precautions.